Alright, so in one of my previous videos, I did some T-joint welds with some dual shield wire because a lot of people say that 035 dual shield doesn't really have any penetration on 1/4 inch material. And I actually discovered that it did not have any root fusion in my last video. So one of the viewers that comments on some of my stuff, he said that I had mill scale on the plates that I was welding on, and that I should remove the mill scale. And because I'm I get stuck in a production mindset sometimes, so I don't even think about mill scale. So that kind of led me to another video here that I wanted to do, and that's talking about mill scale and do you have better penetration with it or without it, or does it even matter? So I've got some plates set up here, and these ones have the mill scale removed, and I have some other plates that I'm going to weld together that do not have the mill scale removed. We're going to find out if you get better root penetration without mill scale. And then I also have this stuff here. We're going to try to do a cut and etch on this stuff. And then I don't know if this will work or not. It's different than the stuff I normally use to etch my welds, but that's all I could find in this town, so we'll see if that works. So what is mill scale and why is it important to know when you're fabricating? So mill scale is like this gray scaly crap that you see on your steel. And when you're doing certification tests, you always remove that, which looks something like this. You can see in the weld area there that I took the mill scale away on these plates. And so mill scale is when they run this stuff through the mills, they make the steel real hot, like red liquid hot, and then they form it to whatever shapes they need to shape it into, and then it cools down. So when that steel is cooling down, when it goes from red hot, pretty much liquid steel to like the solid steel you see here, when it's going through its cooling process, it sucks up gunk from the air around it, and it creates a layer that's kind of junky. And when you weld over it, what can happen is you're pretty much welding on stuff that should not be in your steel, and it makes your welds weaker, and you can get less penetration and all sorts of stuff. That's pretty much the simple way to explain it. You can tell that mill scale is an actual scaling because when you fold steel, when you do that cold, the mill scale will actually start to break up and flake off, which you see here. The scale at the end of the plate there is from my hammer, but the scale breakage that you see near this bend is simply just from the steel flexing so bad that the scaly layer just broke off. So yeah, like I said, I'm not going to try to talk too much on this one, but we got some plates set up. I'm going to run solid wire first. So I'm going to run solid wire MIG over one of these without the mill scale, and then I'm getting some other, these ones I'll set up and I'll run it over the mill scale, and we'll cut and etch them. Then I'm going to be running this this dual shield wire, 035 outer shield 71M by Lincoln. It's the same stuff I used in my last video, and I'm going to do the same thing. I'm going to run it without mill scale and then run it with mill scale. Do a cut and etch and see what we get. And then I cut an extra set of plates so I can either mess up or we're going to run a 7018 and see what that gives us. And then you don't have to set up your plates this way, but since I have this table, I found out it makes setting up even just like bullshit testing plates like this, it's like dead center, perfectly lined up. You know, usually I would just stick it there any which way and weld it, but since I have this table, I figured I might as well use it, and yeah, everything's dead on, perfectly centered. I mean, the plates aren't cut to size, but I mean, they could be if I wanted them to. I was just cutting them with the chop saw over there. Didn't measure nothing, but yeah, you throw this fence block up, slide your bottom piece up against your fence block, put these shims in there. These are 7/8 inch shims. That metal is dead center. So yeah. So I'm gonna get everything tacked together, and then you can see me weld this stuff. Alright, so this first weld, since I already have this machine hooked up to the 9010, I'm gonna run spray arc right here instead of stick welding this one. So this one has no mill scale on it. I took the mill scale off. So let's see what happens. That kind of moved my plate away. I wasn't ready for that. I forgot I was doing some painting on this table, so the ground is not the best, but that shouldn't affect this. I'm going to be cutting it somewhere in here, so again, doesn't matter. So one thing I noticed running that compared to how I normally run spray arc or spray transfer is without that mill scale, it was like actually a true spray. With the mill scale, it likes to pulsate and short circuit sometimes. So that's a pretty cool observation, I think. If you're running spray, the mill scale removal definitely helps. So I'm going to drop this machine down. We're going to be running 315 inches a minute and 22 volts now. I just was at 360 and 28 volts. Now we're running 315 and 22. So this will be a short circuit MIG, no mill scale. So that was with 9010 gas. No mill scale, short circuit. This one will be mill scale, short circuit, same settings. So that was short circuit with the mill scale. This is a little bit thicker than I normally weld with the MIG. So I'm trying to run a little bit higher settings, and the welder looks like it went to jump up to 24 volts. So it was a little bit different than I normally run. Normally I'll run 3/16 material, and I'll be around 280 inches per minute and 20.5 volts. So now I'm going to set up the 035 dual shield wire. Alright, so I went and switched this over to a dual shield wire. I have just about enough 75/25 in this cylinder to be able to weld these two welds and get away with it. The cylinder is pretty empty though, so yeah, this one's going to be the mill scale weld, and this one will be no mill scale. Let's get after it. Alright, set that aside, no mill scale. Alright, so we still have a little bit of gas left. We didn't get completely empty there. I'll let them cool off, and then we're going to do a cut and etch here. Alright, so I just got done doing all the cut and etching. This is my dual shield group. This is my short circuit group. And then this is the MIG, or the spray transfer. I don't know if the camera is going to pick it up. Ooh, it actually does there. So you can see this is the mill scale. This is what had the mill scale on it before I started. You can see we got the same problem. It looks like there's lack of fusion in the root. And then with that etch, you can actually see that a little bit. Look at this screwdriver here. You can actually see that weld nugget barely got into the plate at all. And then over here, where we took the mill scale off on the dual shield, it looks like there's a similar issue going on where like there's something in the root there. But you can see the weld nugget digs way deeper into the plate, and then at the root actually there is that little arrow indentation thing there in the weld nugget. There's still that slag or a lack of fusion or whatever. I don't know what to call that, but it does dig. It dug a lot deeper into the metal. Whereas with this, you don't really see that triangular point there. Like it's just not there. And then this one, the etching didn't come out all that great. But this one was attached to this one. So now we'll go on to the short circuit groupings. I can't remember. Yeah, this is short circuit, no mill scale. I mean, you can see we got some pretty good penetration there. I mean, that penetrated about a quarter of the way through the plate. And I mean, we got like a little nugget looking thing at the root, but I think that's just how the plate was sitting on the other plate. But I mean, it's got some penetration there. Over here, where we had the mill scale, again, the etching didn't turn out the best on this one. But you can see like it barely penetrated into the plate. You can see on this one. And then we have a bigger thing there. Right there. So, yeah, removing the mill scale definitely helped. I mean, it got into the plate there. Whereas on this one, it's about half the wall penetration. At least. And then this is the spray, and I think this one might have done the best. Oops, zoomed in too far there. Yeah, you can see this one. That's probably the way to go. There was no mill scale on this. It definitely got into the root. It didn't penetrate as deep into the base metal as far as like the legs as it did with the short circuit, but it got a better root, I think. We'll throw it over here for comparison. So this is spray, and then this is the short circuit. So definitely, actually I'll move this over here so you can see the difference between mill scale and no mill scale. It definitely looks a lot different. All right, so what did we learn from this? We still have the problems with the dual shield wire having that weird little thing in the root, but we did find out that taking the mill scale off definitely allows you a lot better penetration. Even if it's not in the root, the weld nugget will penetrate a lot deeper into the parent material if you take off that mill scale. So, if you're doing super critical applications, that mill scale removal is probably necessary. If you're just, messing around and making trailer ramps like I do, over here, is it necessary? Probably not. I mean, if you want to, the metal is probably going to bend far before your welds will fail, especially if you engineer them correctly. But if you're doing really critical stuff, if you need to get every last bit of holding strength out of your weld that you can, you definitely need to take off that mill scale. It's something that a lot of people overlook. I even overlook it quite often. But after doing this, I might pay a lot better attention to that. So yeah, hopefully you guys learned something from this.